So today we're going to start our third data tutorial. Specifically, today we're going to learn about data visualization. Data visualization is an important tool and an important skill for data analysts to have because it allows us to understand the behavior and the general trend of data. Specifically, we're going to be creating histograms and scatterplots today. So here is your checklist, like always, and you can pause the video to make sure that you get everything ready to go. Specifically, first thing first, make sure your data is ready to go, and then download the topic to folder. If you're watching the YouTube video, you can download the topic to folder from the description. If you're a student, you already have the topic to folder link on your online learning avenue. And then just double check that all the data sets are there ready to go. The instructor do file, like always, is the do file that we're going to be using for me as a teacher. After that, make sure you create a new do file and save it, and you can title it topic two, or you can title it however you want. This is an important habit to create, which is every time you create a new project, like this time, we're doing a different project from the previous two tutorials. We create a brand new do file so that we don't confuse ourselves. And after that, we write the first 4 lines of code. These 4 lines are incredibly important because it sets you up for success. So the first line is clear. The second line is CD, which changes your working directory. And then after that, you don't have to tell Stata which folder to specifically look for data sets anymore. And then capture log close and log using. And then I just called it log using topic two. And then just make sure you append after that. And then make sure the first 4 lines of code run. So on my computer, I already have the first 4 lines of code. I have clear and cd, capture log close, and log using topic two. And I'm going to append in case there is topic two in my folder already, my working directory already. I can just keep on appending to the existing log file instead of overwriting the log file. Okay, so after you're done with these steps, we're going to click do just to make sure that its data is running and everything is good to go. Okay, so today specifically, we're going to learn two different commands, histogram and two-way. So histogram, by the name, as you can probably imagine, is the code to help us generate histograms. And like always, Stata is very good at providing some help with any kind of code and command. So in the command window, we're going to type help histogram, and this is the help file. So the syntax for histogram is very simple. You start with the command histogram, and then you just put the variable name, the name of the variable that you want to create a histogram with. And then after that, you can have any kind of if condition and then add options such as the number of bins and things like that. So again, this is a really, really good resources for you to get a general sense of how to create a histogram. So today, we're going to start using the dataset country. Okay? So we're going to use the dataset country and we're going to run the do file. And then you're going to see that a country dataset is already loaded. So this country dataset was the same country dataset that we've been using in the previous two tutorials. So basically, it is a panel dataset for all the countries from 1990 all the way to 2020. So we have a bunch of different variables for all the countries between 1990 and 2020. For example, we have the GDP, we have the population total, and things like that. So specifically, one of the more important variable that we want to look at, one of the more important metric that we want to look at about a country is the wealth of the country. So you guys might be thinking, oh, I know we have the GDP here, so we can just use the GDP to measure the wealth of the country. Well, that is true to measure the general wealth of the country. Generally, when we're measuring the wealth of the country, we want to measure the general well-being of the country. And because countries are different in sizes, generally, when we want to look at the general wealth of the country, we use another variable, which is the GDP per capita. And GDP per capita, as you already probably know, is just the average GDP measured by GDP divided by the population. And If you look at the variable list, you're going to see that this variable is not there, but we have the necessary information to create that variable. Here we have the GDP of different countries in different years, and we also have these countries' population in different years. So GDP divided by population is going to give us GDP per capita. So we're going to generate this variable, which is GDP per cap. This is how I'm going to name my variable. It's going to be GDP divided by the variable name population total. So this way, we're going to be able to generate a variable called GDP per capita. And for good measure, we're going to label that variable. And I'm going to call it GDP per capita. Right? And I'm going to click do file again. And you're going to see this new variable GDP per capita is generated on the lower right-hand side. Okay. So the next thing to do is very simple. We are going to create a histogram. Following the syntax, we just type histogram and then the name of the variable that we want to generate a histogram of. And specifically, we want to look at just one single year because I don't want to compare, for example, Algeria's GDP per capita in 1990 with the United States GDP per capita in 2010, right? It doesn't really make sense. We want to compare GDP per capita within the same year. So specifically, in my example, you can choose whatever you want, whatever year you want, but I'm going to choose the year 2000. And after that, I can actually tell Stata how many bins I want, meaning how many bars, vertical bars I want. And then I want to project a normal distribution on top of it just to see the general behavior of the data set. Okay, so histogram, the variable that we want to generate a histogram, let's say histogram of, the restriction of any kind of data set I want to put on, and then additional options. So the first option is how many bins I want to create, and the second option is how do I put a normal distribution projection on top of it. So if I click do, you can see that Stata has generated a graph for me. You can see that there are 1, 2, 3, 4, 5 bins, right? So this is basically what's being generated using our command. At the same time, you can probably already see that just like any other income related variable, there is a intense rightward skewness of this distribution, meaning that the tail on the right-hand side is very long, which means that there are a very few but very extremely rich countries in this world. And basically, this is just a picture showing us income inequality in this world. Okay. At the same time, you can also see this normal distribution being projected onto the histogram. Okay, on the vertical variable, it's just the vertical axis is just the density, basically the probability. Okay, so as you can see, that this distribution is rightward skewed. A lot of times when it comes to statistic analysis, a lot of the measurements and a lot of the calculations rely on the assumption of a normal distribution of a variable. And as you can see that this is not exactly a good normally distributed variable because it's extremely skewed to the right. So one of the solutions to deal with this in economics is to do a log transformation. Log transformation is just taking the natural log of a variable, and the natural log version of the variable will be more normally distributed and more appropriate for our analysis in economic research. So how do we do that? Well, log transformation, like we said, is just the natural log of the variable that we want to use. So we're just going to create another variable called the log GDP per cap, which is just going to be the natural log of the GDP per capita. Okay. And again, for good measure, we're going to label the variable. Right? So we're going to label the variable log GDP per capita, which is the natural log of GDP per capita. Okay. And then we're going to click do. You can see that every time I click do, the Stata runs the entire do file, and then this new graph is being generated. So here is a trick to stop Stata from doing that. And the trick is very simple. If you don't want Stata to run the entire line of code, you can just highlight however many lines of code and just generate from there. Okay? So I'm not going to do that because this variable is already generated. I don't want to generate it again, so I'm good to go. But after that, I'm going to create a histogram, and I'm going to create a histogram of the GDP per capita if the year equals to 2000, same thing. But now I'm creating the histogram of the log version of the GDP per capita, and I'm going to tell Stata I want 5 bins, I want a normal distribution projection, make sure there's a space between your options. And here, I don't want Stata to generate a bunch of graphs. I'm just going to tell Stata to highlight this line of this line of code, and I'm going to click do. And you can see that Stata did not run any other code, only ran this code. And now you can see with this natural logged version of the GDP per capita, there is a more normally distributed variable, right? So the natural logged version is more normally distributed, and that is why it is more appropriate for us to understand the behavior of a variable and appropriate for us to use as our econometric analysis. Okay. At the same time, I can just copy and paste this line of code, and I can choose however many bins I want. So you guys might be thinking, okay, what happens if I have 50 bins instead of 5 bins? Well, if I click do, you're going to see that, well, it gives us a little bit more detailed information, but at the same time, it kind of goes zigzags up and down, right? Still, it's a normal distribution, so that's pretty good, right? So that's telling us is that when we have more bins, it might give us more information. So how about we have 500 bins in this case? Well, if we run this line of code, you can see that this histogram doesn't really show us anything anymore, right? And we see a lot of empty bars. We see a lot of bars or ranges that don't have any bars. And then we have this one observation or two observations or three observations. So now when we have 500 bars, we actually have a lot of bars that are zero. Why is that? Well, it's very simple because we're looking at the GDP per capita of the year 2000. Do we have 500 countries in the world? No, we don't, right? When we don't have 500 countries in the world, of course, you're going to see some countries, there's some ranges that just don't have any countries that belong to that range when it comes to GDP per capita. So this is actually an important lesson to learn when it comes to data visualization, is that just because we want more information doesn't mean that the final data visualization result is going to give us the information we want to know. Okay, here we want 500 bins. Actually, we got less information. We don't really understand what the distribution looks like anymore. So when it comes to data visualization, a lot of times you can make choices like the choices that I made here with a different number of bins, but what kind of choice that you want to make, however many bins you want to make is more of art because your goal is to communicate to the readers about what you want to say. You need to make the educated guesses or educated judgments about what is the most appropriate options we're going to choose. Okay, does that make sense? Okay, so one more thing I want to mention. So if we click this do file again, well, if this is the graph that we want to save, which is not, but there's one thing I want to emphasize. So if you click save, then this graph will be saved in a file format called GPH. So GPH file format, it can only be opened by Stata because it is a file format you can use Stata to manipulate further into more detail. But generally, when we create a graph, we don't really want to make a lot of changes to the data, to the picture, to the graph. GPH is not exactly a easy to open file format because unless you have Stata, that file just cannot be opened. So one trick to save the picture in a different format is just to click File, Save As, and then you can see that it defaults to Stata graph, but you can choose JPEG to save that file if you want to. Okay, I'm not going to do that because this graph is not exactly that good, but this is how you save pictures in Stata. Okay. All right, so we are done with histogram. The next thing we're going to learn how to do is we're going to learn how to create a scatter plot. So scatter plot is, as you can imagine, it is a plot where instead of having one variable is two variables, we want to look at the relationship between two different variables. And because now we're looking at two different variables, though the overarching s- concept of graphing is that we're looking at the variables of two different axes, and the command is two-way. So again, we're going to type help two-way, and then this is the graph that this is the syntax we're going to be using. So as you can see, in front of that two-way, there is this little thing called graph, and it's put in the square bracket. So whenever you see a syntax with a line of code, with some code that's put in the graph, put in the square bracket, it means in this case, this part is not necessary. So you can just start typing two-way and start plotting your graph, you're okay, because Stata knows that as soon as you type two-way, you are creating the graph. So this graph part becomes optional. And if we click scatter, you can see that here it's two-way scatter the variable names. And here in this case, in some cases, the two-way part can actually become optional. And another thing we want to mention is that if you sometimes you can just see that when you look at a code, you can see that there are certain first number of characters that are underlined. That's data telling you that instead of typing two-way, you can just type TW and Stata knows that you're trying to type two-way. And the cool thing about Stata is that you don't only have the choices of typing two-way or TW. You can type TW, TWO, TWOW, TWOW A, TWOWAY. So any of these things you can have, you can you can type and still knows that you're trying to type two-way. So again, two-way scatter. So this is how you tell Stata to create a scatter plot, and then the variable list. The thing to pay attention to is that the variable list follow that here. The variable list should be y and then x, meaning the first variable will be the variable on the vertical axis, and the second variable will be the variable on the horizontal axis. Okay, so always remember that. So here, we're going to be using a different data set to do what we want to do. So first thing first, we're going to clear, and then we're going to open a data set called county.dta. So this is different from the country.dta. Now we're looking at county level data. All right, so I'm going to highlight these two lines of code because I don't want Stata to generate a bunch of graphs for me. So I'm highlighting these two lines of code, click do, and you can see that Stata has opened the county.dta dataset for me. So the county.dta dataset is kind of similar to the country, but instead of a panel dataset for all the countries, it's the panel dataset for all the counties in the United States. So I start with Alabama, and then we can go all the way to West Wyoming, right? So we have all the information over here. Again, it's from the same time period from 1990 all the way to 2020. So this is the county.dta. Okay. And we're going to learn how to create a scatter plot. So again, the two-way part is optional, but usually for good measure, we just type two-way. It doesn't hurt. So we type two-way scatter just to remind ourselves now we're looking at the x-axis and y-axis. But remember, when it comes to the variable list, the first variable is always the variable on the vertical axis, and the second variable is the variable on the horizontal axis. So in this case, if you look at the data set, you're going to see that there's a lot of information about different counties. Specifically, my question is there a relationship between a county's wealth and a county's unemployment rate? Because theoretically, you should think that a county that has a lot of unemployment should be relatively poorer, and a county that have everybody is employed should be relatively richer, right? So this is an example to see a negative relationship between the personal income per capita of a county and the unemployment rate of that county, right? So that's what we're going to do. So the vertical axis we're going to choose is the personal income per capita. So this is the average wealth of a county. And then the horizontal axis is the unemployment rate of the unemployment rate of the county. At the same time, remember, this is a panel data set. I don't want to compare different counties across different years. I just want to compare different counties within a year. So I'm going to choose randomly 1 year. Okay. And then on top of that, there are just way too many counties in this country, and different states might have different policies that affect the different counties differently. So I want to restrict my data set to just one single state. So I'm going to restrict my state. You can see that there is a variable called state code. So I can just tell Stata to look at a specific state. Okay, so my state code, I'm going to look at, for example, Tennessee. Okay, because this is where I teach. So um, this is the line of code that creates a scatter plot for me. Okay, so I'm going to highlight this line of code, click do, and there's an error. So it seems like there's some issue with my data. What's the mistake here? Okay. The mistake is right here because remember, one equal sign means directing is an action, and two equal signs is a condition. In here, the state code should be conditioned. So this part is saying state code is Tennessee. Now state code should equal to Tennessee, right? So this is my mistake. Now, if I run this line of code again, you're going to see that now the graph has been generated. The vertical axis is the personal income per capita, and the horizontal axis is the unemployment rate from the Bureau of Labor Statistics. Okay, so now you can see that there is a pretty negative relationship, meaning counties that have higher unemployment rate tend to be poorer counties. All right, so that is what we want to learn. So you guys might be wondering, okay, so now we have this graph, and let me generate it again so I can show you. So now we have this graph. What if we show people a clearer image by creating a trend line on top of that? And it's very simple. We can do that too, but we're going to do it a little bit more, uh, with a little bit more finesse. So we're going to create this line of code. And then we're going to keep the same conditions over here. Okay. So you can see that now, instead of just two-way and scatter, I put the scatter part and the variable list in a bracket. And then I create another part, which is LFIT and personal income per capita and unemployment in another bracket. So basically, when it comes to Stata creating a graph with two different kinds of elements to it, a scatter plot and a trend line, Stata is basically putting this graph, this trend line graph, on top of the scatter graph. So we're stacking two graphs on top of each other with the same vertical axis and the same horizontal axis. And that is why we need to tell Stata that this one and this one are two different graphs. We're just stacking them, so we need to put them in separate brackets. Okay, and outfit, you can do a help if you want to, but outfit just means line of best fit. It's basically a regression line between personal income and unemployment rate. So everything else is the same, the condition, everything else is the same. We click this line of code and then we click do. You can see that now there's a trend line. So that tells you overall, on average, there is a negative relationship between unemployment rate and the vertical axis, which is the personal income per capita. Okay. All right, so that is an example of creating a scatter plot. I'm going to give you another example of creating a different type of scatter plot, and this time we're going to create a scatter plot using the dataset mean wage by education and gender.eta. And this line of code is actually going to be relatively complicated. So I'm going to type out this line of code. So this is my code. You can see that this code actually has a lot of information to it, right? So here I'm typing two-way again, and the first graph that we're creating is a scatter plot. And here I'm using the data set mean wage by education and gender. So if I run these two lines of code to load the data set, you're going to see that the data set is just the average wages of men and women in 2019. And the education level 1, 2, 3, 4, and 1 means less than high school, 2 means high school, 3 means some college, and 4 means more than college, or college and graduate school. Okay, so here, the first element or the first graph I'm generating is the scatter plot between education and income wage, the income wage and education. And sex equals to 1, that means the person is male, and sex equals to 2 means the person is female. So the first scatter plot, I'm creating the education and wage relationship for male. And then the second scatter plot, I'm creating the education and wage income information for female. And you might see that here is this thing called M symbol that's basically telling Stata I want a symbol that's medium size and it's a dot. And here I'm telling Stata there's a medium size and it should be a hollow like a circle. And then on top of that, I can also further specify or further customize my graph by having the title of the y-axis, the title of the x-axis, the label of the x-axis, so people understand what 1 stands for, what 2 stands for, 3 stands for, 4 stands for. And then I can also create a legend where the first one is male because the first graph that we created is male, and the second one is female because the second graph we created is female. And then I can actually create a title to the graph. Okay, so this is an example of how much you can customize your graphs using Stata. So if I run this line of code, this is a relatively easy and relatively easy to understand graph, right? So here you can see that the male is going to be this blue dot, these blue dots, and the females are going to be these red dots. And you can see that no matter which school level we're looking at, there is a average gender income gap, right? Males generally earn more than females. Okay, so this is a rough representation of the gender income gap in the United States, right? So that is another example of a scatter plot. And then there's going to be one more thing that we're going to learn towards the end of the tutorial. We're going to learn how to create a line graph. So a line graph is the graph that shows you the trend of a certain variable over time in general. So we're going to clear and use a brand new data set called US time series law.dta. Okay, and I'm only going to run these two lines of code just to show you what the data looks like. So here I have a time series data set in the United States, and I have the population of the United States and the GDP of the United States. So basically, I just want to look at, how population and GDP changes in the United States over time, right? So I have a bunch of different years, and then we're gonna just go from there, all right? So here, for example, if I want to create a line graph, I can just type two-way line, and then I can just type GDP and year. Remember, GDP, the first variable is the variable that's on the vertical axis, and the second variable is the variable on the horizontal axis. I want to track the GDP of the United States over time, so I'm just going to type two-way line GDP year, because GDP goes on the y-axis, year goes on the x-axis. Okay, so if I run this line of code, it's kind of weird, right? This graph does not look like the graph that we expect to see when we're looking at the GDP of a country, because it should just be one line. Why is it all messy? Well, the reason is very simple. So if you look at the data set, you're going to see that the year is actually not arranged properly. It starts with 1963 and then 2008 and then 1986 and 1981. So because Stata trusts that you know what you're doing, what Stata was going to do is it's going to start the GDP in 1963, try to connect the GDP in 2008, and then try to connect the GDP in 1986 again, and then try to connect the GDP in 1981 and 1966 and 1976, and so on and so forth. So basically, Stata is going this back and forth and back and forth and back and forth motion and keep on connecting all the dots. So this is an example of us understanding that we, the people, are actually the people that are actually the party that should be paying attention to our data sets so that we don't generate graphs that don't really make sense. Okay, so here the solution is very simple. I want to look at the GDP over time. So I should probably arrange my GDP according to time, right? So the code is very simple. I'm going to type sort year. This way, the data set will be sorted according to the year. So I click that line of code. You can see that the data set has been arranged, rearranged, or sorted from 1960 all the way to 2020, 60 years, right? So given that that's the information, now let's run two-way line, GDP, and year again. So if I run the same line of code again, you can see that here, this gives us more information about the GDP trend over time in the United States. And you can see that in the United States, the GDP has been increasing pretty steadily, but then you can also see these, downturns and changes in trends over time. And we can see that this is the Great Recession in the late 2000s, and then this was the COVID downturn in 2020, okay, in 2019, 2020. Okay, so this is how we generate line graphs. Just to make sure that if you generate line graph that tracks something over time, you need to make sure that you sort your data set according to time. Okay, so this is all we need to learn for today's class. We have learned how to create histograms. We have learned how to create two-way scatter plots with a line of best fit tacked on top of it, and then we also have learned how to create a line graph. Right. So before we do anything else, we need to save our do file. We have done really good work. Save your do file, and then it's safe to close your Stata. Okay. All right. Thank you very much. I will see you guys in the next tutorial.